So if you've ever wondered why console.log might run before a fetch request finishes, it's not necessarily a bug, but it's actually how JavaScript works. And once you have a better understanding of the event loop, you'll finally understand why async requests behave the way they do as well. So in this video, I'm going to show you how the event loop actually works, why callback requests can be a little confusing, how promises actually fix those problems, and why async await is now the gold standard whenever you need to make an external request. So with that said, let's jump in and get started. So first, the event loop. JavaScript runs in a single thread. It can only do one thing at a time. So how does that handle things like set timeout, fetch, or clicking the button? The answer is the event loop. Think of it like a manager. You got a call stack. The list of functions is being executed right now, and you've got a message queue, a line of tasks waiting their turn to be ran. When the call stack is empty, the event loop is going to grab the next thing from the queue and it'll eventually run. That's how async code works behind the scene. Now let's talk a little bit about callbacks. Callbacks are functions passed into other functions like this. In this example, we're using setTimeout, and we'll log to the console hello after 1 second, and we're passing in 1000, which is going to represent the time that we'll like to delay this message to the console. The callback is not going to run right away. It's going to get this to the queue, and it is going to wait until the call stack is clear. That's why your other code is going to run first. But here's the issue. Callbacks can get messy very, very fast. You might end up with something like callback hell, if you will, where one function is nested inside of another. And that could be a little hard to read and extremely hard to debug. But that's where promises come in. A promise represents something that might finish later. The way that code works is like this. In this example, we're making a fetch request to an endpoint of API/data. Then we'll take the request and we'll convert it to JSON, and we're going to log that data to the console. This is going to give us a cleaner way to handle asynchronous results. Instead of nesting everything, we can with the chain.then methods. But even promises can be a little chunky if you need a lot of logic. That's why we have async await. So here's the same example, but using async await instead. In this example, we have an asynchronous function named getData. We have a try-catch block within it. The try portion is going to make the fetch request to the API endpoint. We'll capture the results in a variable named data, and we'll log that data to the console. And if we do get an error, we're going to console that error, stating that something is wrong and passing in the message. This method is much cleaner, right? Now it looks asynchronous, even though it is still async behind the scenes, but you can use try-catch blocks for error handling, and it's going to read step by step, kind of like a recipe. So which one would you rather use? For my personal experience and advice would be callbacks are okay for simple tasks. Promises are great for like chaining of a few things. But async await is preferably the best way, and it makes it a lot cleaner and a lot readable. So in conclusion, the event loop explains why async code behaves the way it does. And once you understand the call stack in the queue, that mystery is going to kind of disappear. Then you've got your tools, callbacks, and other simple stuff, promises for chaining, and you'll use async await for cleaner, more modern syntax. And now you have a better understanding of how to use all three. And if this video helped you, consider giving me a like and subscribing, and I'll see you in the next one.